So now we'll talk a little bit about programmatic access to the OpenAI models. So first thing to consider is there's a lot of different models you can use. And these vary in sort of their functionality and their performance as well as their cost, right? So there's GPT-4 and GPT-4 Turbo. And the difference between these is cost and also the context window. So how many tokens you can put into it. So these are things to consider based on the kind of task you're trying to compete. There's also 3.5, so this is the older model. This is what the base free ChatGPT on the site runs with. And so for more simple tasks, this is something that you should consider. There's no reason to sort of spend extra money if you don't have to when performing these types of tasks. And then there's also some other models that might come in handy at some point if you're curious about them. So there's DALL-E, which is image generation. There's text to speech and speech to text through TTS and Whisper. And they also have embeddings that can turn text into vectors. So these are all sort of nice models that we've used some and work quite well. So they provide a Python library, which you can install through pip. And just a note about API keys. I don't know how many of you have ever worked with API keys, but it's important really to keep your API key private and protected. So this is something that you never want to publish or share. It's also something that you don't really want to put directly in your code. Because think about maybe a case where one day you want to upload your repository to GitHub so you can track your changes and collaborate with someone. And you have your key in there as a string, and then someone racks up a huge bill on your OpenAI account, right? So this is something that you want to put in a .env file. So this is stands for environment, right? So it's an environment variable. And you can add that .env file to a .gitignore file. So that just means, hey, don't put this in a Git repository. So you can see the way that we're accessing this in the code is by we're loading that .env. You can see sort of explicitly saying that, and then bringing that value into your code without explicitly stating it as a string. So just a note. So please be careful if you do actually choose to go create an API key. And similarly, there's a package in TypeScript slash JavaScript that can be used, and it has very similar syntax. And we're going to sort of use our OpenAI key in a similar way, grabbing it from our environment variables. Specifically, we'll be talking about the Python package, though. So sort of the most basic endpoint, the one that you probably are most familiar with from if you've used the online version of ChatGPT is this chat completion request. What a chat completion is we're predicting the next characters or the next tokens that will come. So for instance, a question and an answer, or a question and a description, whatever that may be. And there's sort of a variety of inputs and parameters we can provide to this endpoint that will give us a little bit more customizability and control than sort of just using the web interface. So some of the main ones are and required ones are model. So this is that when I showed that list of models, this is a string representing which model we're going to use. So this could be GPT-4, GPT 3.5 Turbo. There's a full list on the site, and you can sort of choose an appropriate model for your task. And then messages is actually we're going to keep track of all the back and forth sort of that's gone on so far, as well as any new prompts that we're providing to it. And each message is going to have two fields, which is the role and the content. So content is pretty self-explanatory. That's the actual text that's being produced. And for the role, we have three different roles that we can have. So system is going to help, like I said before, guide the overall behavior of our model. This is not required, but it can, like I said, it can be very helpful. The assistant is going to be any content that the chat completion's endpoint or the model itself is producing. And then user is your actual prompt. So that's where you're going to insert your questions or your task into this messages array. So here we can see sort of a basic example of your bioinformatician's assistant. And we're asking about gene expression analysis, different methods for it, and then it's going to respond and tell us about some of those. And it goes system, user, and then we get that response from the assistant. Some other helpful parameters to pay attention to our temperature. So this is going to determine the randomness of the model's responses. So if you want a more sort of controlled or less creative sort of value, then you want to go closer to 0, and a higher value will make those values more random. This is something definitely to just experiment with in the task that you're trying to accomplish. Frequency penalty will basically make it so it's the model will give less repetitive answers. So a frequency penalty is somewhat descriptive. It's saying the more that we have these same words and tokens appearing, it's going to be penalized for that. And then we can also control the max tokens that it will produce. So if we're sure that our answer should only be less than 10 tokens, then you can put that in and ensure that we're not sort of wasting extra token generation at the end of our response. So this is actually the object that we get back from this endpoint. So it's not just simply the content, but a bunch of other information, some of which can be sort of helpful. So we have when it was created, we have the model that we used, and we also have inside of this choices array. So the reason it's array is because we can tell it to produce multiple responses to our prompt. But for the most part, you'll probably only be producing one. So it'll be the first sort of index in this choices array. And we have the content, and we also have a reason why it finished. So if you're using arguments like max tokens, or there's also a way to stop at a certain token. So if we see, for instance, an end square bracket or something like that, we can stop the generation. So this can be an important thing to look at in that case. So getting the actual content of the response, which is likely the only thing you're really going to need from this, is by just indexing into that array and grabbing the message and content fields. So that's sort of a simple introduction to this object. There's obviously a lot more in there, like the usage, so you can see the total amount of tokens you used with that request as well. But the main thing we're going to want is that content. So the way we actually now provide context or continue a conversation through this endpoint is that we have to append messages to this message array that we're passing it when we're passing it to the endpoint. So here, if we get a response to a certain message, then we can extract the content and the role. We can append the messages to a messages array, and then we can put our next question in there as a user. And then the model will refer to that whole conversation history when answering your next question. So for instance, in this example, we're grabbing 5 genes, and we're telling it should be NCBI gene symbols. We're going to append its answer to our messages array. Then we're going to ask for an explanation of each gene. And then we're going to get our response back, and we can see that we got our list of genes, and then we got an explanation for each gene. So this can be sort of an important thing to consider, because a lot of studies in this sort of more recent 6 months to a year have seen that multi-shot prompting can improve model performance somewhat significantly, and especially in a context of a task that requires some critical reasoning. So asking the model to think about what it had just said, or to reconsider or find flaws in its original logic, can help improve the actual end result of the response that you're getting. So another really sort of powerful aspect of this chat completion module is OpenAI function calling. So this was something that was actually released earlier last year with GPT 3.5, and it also is supported by GPT-4 now. We can actually provide tools to our model that they can use, that it can execute if it decides that the prompt sort of matches a description of one of those tools. So in these tool descriptions, we're basically passing it, that we have a function here, and this function can get the current weather. And for its parameters, it just needs a location and then a format, which is either Celsius or Fahrenheit. And it also gives a description of those inputs. So this is a city and state, such as San Francisco, California, and the temperature is just the unit of temperature. And then we can also see that we're requiring both of those inputs. And then we have sort of a similar function definition down here that's looking for a forecast a certain number of days out. So we can do this quite easily with our own functions that are sort of might be relevant to some research that you're doing. So for this specific example, we're looking at getting publications for a certain gene. So we're finding a bunch of PubMed articles that have mentioned a gene symbol. And we're going to translate this function, which is, by the way, just querying the MyGeneInfo API. And we're going to translate that into a tool definition for OpenAI. So we can see that we have a very similar format to what we were looking at on the last slide, which is get gene publications. We have the function name, we describe what it does, and then we describe the input. And now we can actually pass this to our chat completion request. So we're still on that same endpoint, and it has an optional parameter to pass a list of tools. So we've passed it that list of tools, and we've asked, can you provide publications that mention lag3? So we can see here, we're just using some color to define which type of message this is. So we have a system prompt here, and then we have our message as the user. And you can see it actually didn't respond with text to that message. Instead, it saw that it had a tool that was applicable to the task at hand, and it called it. So it says, hey, I want to call the get gene publications function where the argument gene is lag3. So that's exactly what we wanted. And then we can parse that output. So we have this function that has this call, and we have the name of the function. So we can do a little bit of parsing to grab that name and evaluate this JSON object. So this is it's still as a string, right? So you can see the single quotes out here and then the double quotes. So we're just going to parse that into an actual object. Gene is the key, and lag3 is the value. And then we can use a little function mapping. There's a few different ways to do this, but for here, I'm just going from the string to the actual function that we've defined before. And then we can execute that function. We see that at the bottom here, we have a bunch of PubMed IDs and then text where lag3 was mentioned. So you could see how this would be helpful, specifically in providing accurate information to the model. So in this case, I'm just printing out the result, but you could actually take this output and then go give it back to the model, right? So then it has the context of what you've queried. So this broadly falls into this category of integrating sort of a knowledge base or knowledge outside the model that it can use. So there's many different ways to do this. The tools is certainly one of them. And you could think about other ways that you might want to do this. So if you had a knowledge graph or a graph database, you could think about making functions of Cypher queries, sort of predefined Cypher queries where you can input different arguments into it. And then we can provide that information to the model so that it has some sort of accurate or pre-vetted, predefined information that it can use. We can also sort of do this sort of task with these predefined APIs. So here I was using MyGeneInfo. You could imagine sort of implementing a bunch of other functions that call different APIs for different information about genes. And now you have sort of a AI assistant that can answer all these questions about genes quite accurately, right? Because we're grabbing information from outside sources. We're not depending on this sort of massive amount of text that it's been pre-trained on. We can also look at corpuses of text documents, and we can measure text similarity. So we can convert them to embeddings. We can do a vector search, things like this, which is something I'll talk about in a little bit. And we can also fine tune our pre-trained LLM. So this isn't something that we've done extensively, but it can be helpful to sort of provide the specific type of data or the specific type of queries that we want to the LLM to train it further, to fine tune it to a very specific set of tasks or a specific set of data. And there's the last thing I'll mention is this information retrieval, which is implemented as a part of OpenAI assistance, which I'll talk more about. And this basically gives us the ability to upload documents and then have a sort of vector search already implemented for it that I talked about here. So these assistants are very helpful in sort of a multitude of ways. One of those is information retrieval. But it also has access to this function calling that we talked about before in terms of providing it a list of tools and functions that it can call. And then finally, it also has access to a code interpreter. So we can actually write Python code and execute it in a sandboxed environment. So the code interpreter is is very nice. So like I said, it's in a sandbox Python environment, and you can actually provide it files. So you can give it CSV files, for instance. You can give it sort of code files or Python scripts, and it can actually then go produce different new CSV files or images of graphs. And it can actually iterate it on itself when it fails. So I'm sure, as you know, if you've tried to generate code with ChatGPT, it often fails on your first attempt. Well, it can actually go back and iterate on itself to try to improve that code and produce the result that you're looking for. So this is kind of how you might attach a file in the context of the code interpreter. So here we're attaching a file that basically is the script that lets us sort of speak and output. And when you upload that file to OpenAI, you'll get a file ID back. And when you create an assistant or a thread for assistant, which we'll talk about more, then you can actually attach that file ID, and then the client will have, or the assistant will have access to that file. So in the context of the code interpreter, maybe this is a CSV file with data you want to analyze. So knowledge retrieval, which I talked a little bit about before. So this is basically going to help augment the knowledge of our assistant with information from an uploaded document. So when we upload a document or a file and then attach it to an assistant that has one of these tools, so this is like the same sort of tools array that has all your functions in it. If it has one that is for retrieval, then that file is going to be chunked. It's going to be indexed, and it's going to be stored as embedding. So kind of what I talked about before, it's going to implement a vector search of your document or documents. And when it finds a part of that document that's relevant to a query that a user has given, it's actually going to provide that to the model, so then it can reference that document and the information in it. Something else to note, if you decide to do something like this yourself, there's a charge for basically indexing and storing these documents. It's relatively low unless you're using really, really big files. So it's 20 cents per gigabyte per assistant per day. So if you have a text file, that's not going to be, it's going to be like some fractions of cents per day. But just to note,